So this is a tale of two oceans. Now, in our previous session, we did some oceans called the Tethys Oceans in the Asian region, or extending from the Alps right across to the east, really as far as Siberia or China. And they were the Tethys Oceans. But now, two oceans that existed pretty much like the Atlantic, but before the Atlantic itself. So hopefully, here we go. Today, we're accustomed to the plates. We're not really accustomed to them, but that's how the plates are today. Huge Eurasian plate. And of course, the biggest plate is the Pacific Oceanic plate and the North American plate, but these have not remained so. They're in the process of cracking up as the Australian plate is today. And as we go back in time, of course, the North American plates had all sorts of pieces joined together to make its present shape. We're going to look at those two patches, Britain and Europe, and Greenland down to about New York along the eastern seaboard of the United States, and try and trace their history a little bit, because it'll tell us something about the ancient oceans that preceded the Atlantic Ocean. North American and Eurasian plates today are actually complex collages of smaller plates, many of which were derived from the southern continental mass, Gondwana. So we're telling you in advance that many bits of those two circles actually were derived from the southern continents, Gondwana. It's going to be a problem. I'll now discuss the origin of Western Europe, Eastern North America, that is separated currently by the Atlantic Ocean. Whoa, if we look at 500 or 600 million years ago, 600 rather than 5, and we're looking actually near the South Pole, for goodness sake. There's Laurentia, which is USA, Canada, and Greenland, and dear old Gondwana, although we didn't really refer to it as Gondwana 600 million years ago, but they've put the continents in a reasonably close association there. You'll notice Australia is straddling the equator down at 7 o'clock. But a little bit before that, we were actually joined on the western coastline of Laurentia. So we didn't have an Eastern Australia. You see right up there at 10 o'clock, we've got at 800 million years, 200 million years effectively before this particular presentation. The two dotted lines were joined together. There was no Rocky Mountain system. There was no Eastern Australia. And we were somewhere along that coastline, looking pretty close to Denver or somewhere from Adelaide. Pretty an amazing picture. You can see Scotland and Northern Ireland mapped against Greenland. And they were pretty near the South Pole at that time. A red patch right out there at 2 o'clock that I've added to this diagram says New York to Warsaw. So there's a funny patch that sat there on as Venezuela or somewhere in West Africa, Guyana or somewhere, which is actually where the areas of New York and Nova Scotia, Newfoundland, England, parts of Holland, etc., and Germany, right across to Poland, came from way down there, stuck onto Gondwana. So it's amazing to say that the politics of Scotland and Northern Ireland seems to be very separate from the origin of England and Wales, and even Southern Ireland, which are part of that red mass. They were entirely separated some 600 million years ago. Scotland, Northern Ireland could claim to be quite near the South Pole, where the others were getting to be nearly equatorial. So on that map, they marked Dalradian rocks of Ireland and Scotland. Well, they're basically the billion-year-old rocks that we associate with the older rocks of the northern part of those two sections, Scotland and Ireland. So there were, I'm telling you now, there were two precursor oceans to the Atlantic. The Iapetus, which is actually the father of Atlantis in Greek mythology, I believe, gets much more attention. But there's a second one, And the reason it gets attention is in Europe and through the Appalachians and even through Norway, Caledonian mountain system, you can see the suture, earliest of the oceans, the Iapetus, whereas the one that followed it, the Reikos Ocean, I think that's named for the nephew of Atlantis, it was the one that brought the British Isles closer together. Here's how all that sort of thing happened. So looking at more or less today's structure, or call it pre-Atlantic Ocean, you've got Canada and Greenland, okay, but on that side of the ocean, you have Scotland, Ireland, Newfoundland, etc. Whereas on the southern side of the ocean, we can see England and Southern Ireland, the very tip of Newfoundland and Nova Scotia, and the New England section of the US and Canada, running down as far as New York. Now, this was first picked up, oh goodness, nearly 100 years ago, I suppose, by paleontologists who realised that either side of a strange line that they couldn't explain, you had two different faunas of trilobites. They knew they were the same age from other fossils, but the trilobites were different. And strangely enough, they called them equatorial for the green ones, and polar, not polar, but anyway, cold environments for the northern one. And they were perfectly correct, as it turns out, when you twist all the plates around and get it back to what we believe. The trilobites, these are the things that are a bit like Moreton Bay bugs that lived 500 million years ago and right through to about 250 million years ago. Well, in Scotland and Northern Ireland, they were the same as the western part of Newfoundland. So they were Arctic, is the phrase, Arctic in character. They thought they were cold faunas. And whereas in England, Newfoundland, that is the Avon Peninsula, southeast of the capital, St. John, and in Nova Scotia, cutting through somewhere near Halifax, you had this other fauna, which was a bit warmer in character. And they couldn't explain it, of course. For 40 or 50 years, they had no idea why these faunas were so displaced as they were joined together of a suture that runs along Hadrian's Wall and through the centre of Ireland, actually. So the suture is the stitching up of that ocean, the Iapetus Ocean, the very first one that existed 450 million years ago. The suture separates those two distinct faunas of trilobites. Now, the Rheic Ocean did much of the business that joined or closed that ocean. You know my story of how oceans originate. In fact, I'll go on and do that, a little bit of a discussion, I think, shortly. But suffice to say, this is a different look at all those continents, and we haven't put latitudes and longitudes on this diagram, or the people didn't, but they showed how great masses of continents always had some character or some existence. Laurentia being Northern America and Canada, Greenland, etc. The Baltica mass, which included Scandinavia, and what had been a long-living group, the Gondwana group, which included South America and Africa. Actually, Australia, etc., haven't been added there, although they were part of the business before Africa really came together. However, Scotland, Northern Ireland, tucked in there in the region of stretching from New York through to Newfoundland, that orange thing at 9 o'clock. And over on the northern section of Gondwana are all these white masses. And these went in every direction. They went, little oceans sort of separated between them, and rift valleys formed, and some became oceans like the Red Sea and moved them offshore. Others became broad oceans like the Indian Ocean of today and moved blocks miles around, or thousands of miles around, and blocked them onto Baltica or actually onto Laurentia. Now, I wouldn't worry about the bottom right-hand corner here, where the cratons are labelled in age. But if you do see a red colour, the 0.9 GA stands for gigaran. So you're really talking billions of years there, 1.25 billion years for the black. Well, yellows are 1.5 billion years. We won't worry about that, but they're the oldest blocks. Strangely, they haven't put any in Canada or in Baltica, where they exist also. You could put one of those funny circles in each of those blocks, and also on Greenland. The writing just says Rodinia broke up. Well, now perhaps I should say something about Rodinia. There's a sort of symphony with the Earth's land masses, that they come together and then separate, and they come together and separate again. And there's been 3 or 4 of these comings together. The most recent one is the supercontinent Pangea, of which Gondwana was a southern part. But prior to that, about 1 billion years ago, there was Rodinia, a mass of continents, as shown here roughly, but although it should include, very definitely should include Australia, India, Antarctica, tucked on the bottom of this diagram for Rodinia. But it tended to break up about 700 million years ago. And we get evidence of that in South Australia very clearly, probably one of the best records in the world of the breakup of that supercontinent Rodinia about 700 million years ago. In fact, the very rocks about Torrens Gorge are dated about that age, and the breakup probably occurred before the ice age of the Sturt Gorge, some 670 million years ago. And so it's really right on our doorstep. These funny blocks that are separated, many of them in northern Gondwana there, between the Amazon, or what's called Amazonia, it's really Venezuela and areas around the Caribbean of today, around the West African margin, that migrated across a series of small oceans and bigger oceans that existed in the last 600 million years. I don't know that I'll go into much detail there. Again, it's trying to show us something. Yes, well, it does show us a further stage where the southern continents of Gondwana are down over the South Pole by this time, and an ocean is open, separating several slabs. One's marked AE near the centre of the diagram, and another one EA and WA. That stands for East and West Avalonia, named from the Avalon Peninsula of Newfoundland, which was part of that, down in the south and west Avalonia. But up in the north, if you can make it out, there's a little bit that's supposed to be England and Wales, and the southern part of Ireland, just near the EA, sitting slightly towards 10 o'clock from the centre of this diagram. And that was moving towards Laurentia, towards 9 o'clock, as a result of this Rheic Ocean opening. And as it split away from Gondwana, it carried blocks with it, and a second ocean probably opened. And those faint red things that are docked in against Gondwana there, if you can look down at the 7 o'clock position, you see the faint red and the arrows pointing up to those 2 blocks. Well, that is where they came from. And by 450 million years ago, 2 oceans had opened, the Iapetus Ocean, which was present in the last diagrams, and now the Rheic Ocean. And of course, as the Rheic Ocean spread, something had to give, and the Iapetus Ocean crust, 100-kilometre thick crustal slabs, slipped in underneath Laurentia and built mountain ranges and caused granite intrusions and volcanism and all sorts of things, so that ultimately the Iapetus Ocean closed. on that central block, WA and EA, that's Avalonia, you had the areas of New England and Maine, and even England and parts of Northern Europe as far as Warsaw. On the southern block, marked with just a simple A, that's known as Armorica block, there must have been some separation or a second rift broke it away, and it might still have been carried on the Rheic Ocean as it enlarged, or there may have been a smaller ocean like a Red Sea that separated it, but ultimately it became the Brittany Peninsula and parts of Central Europe. You'll often hear the term flight from the poles. With respect to the supercontinents, there was often a situation where they aggregated around the poles of the Earth for some reason. And I might be exaggerating in saying that, but as the continents broke away from the supercontinent, they tended to move away from the polar regions. Well, Australia has moved away from the polar regions, so has South Africa and India, for example. And it's just a pattern we can't explain, not even sure that it's a repeating pattern properly, but here it was some 450 million years ago as the original Rodinia continent broke up to build Pangea, the more recent supercontinent. So we've got two oceans there. The Iapetus Ocean, older one, probably was subducted both to the north under Laurentia and also under Gondwana. I won't go into the details of that, but that resulted in all sorts of volcanism and so forth along those two borders, and that's 500 million years old, but it's very prominent in the rocks of those regions. I won't trouble us further, but Avalonia was originally along the Gondwana margin. It was a block that split away with a new rift and resulted in the second ocean. And it actually caused the closure of Iapetus. As it expanded, something had to give, and the subduction of Iapetus Ocean continued apace at that point. Rheic Ocean carried Avalonia northward as it spread. It must have been north of the rift, obviously. And if you imagine the expanding ocean, then Avalonia went northward. Now, I wanted to draw attention to the fact it gets confusing, this movement of plates. I'll just draw attention again to the Somali plate that is spreading off Africa today along the East African Rift. And we'll talk about that for a moment, because this is the process that was going on with things like the Rheic Ocean. Okay, so the African plate as we think of it today, if I was discussing it in broad terms, I take the plate from the central Atlantic at 11 o'clock right across to the central Indian Ocean. And I wouldn't bother to mention the fact that it's breaking in two into a Nubian plate, which is most of Africa, and the Somali plate, which is east of the African Rift. But if you look at the red lines that cut down the African Rift from the Red Sea almost to the Cape, you can see red is expanding and cracking away. Green is just where the plates are sliding past one another. And so that entire region is as if you were pulling them apart, and a new plate is forming, which will carry Madagascar with it, for example, and it could move Madagascar towards Australia, and should the eastern border of that decide to subduct under the eastern side of the Indian Ocean, it'd come halfway to Australia. That'd make our holidays much easier. We've got one planned next year to Madagascar too. Anyway, only in the south is there any pressure involved in the plate. You can see a bit of a blue line near the southern border where, because that Somali plate is tending to move southward, it must be crumpling up the ocean crust. But remember, they're 100 kilometres thick or so, these plates that are moving around. So that's how the first separation of these slabs of Gondwana, which include things like England and Wales and New York, all on one slab, that's how they first moved away from Northern Africa and Venezuela of South America. So the East African rift, I'm reading this now, without an F in the rift, separates the Nubian and Somali plates by continental rift boundaries, which are shown in red, and continental transform boundaries, which are the sliding ones in green, and in one case, an oceanic convergent boundary that's pushing together right down in the south, which is shown in purple. So what happened next? You'd call the East African rift a developing divergent tectonic plate boundary. So the plates are separating, that's what it means, where the African plate, the process is splitting into two tectonic plates, the Somali and Nubian. And that's happening at an appreciable rate, 6 or 7 kilometres every million years, which is the same as saying millimetres per year. So as a geologist thinks in million years, it's going to separate at a reasonable rate, 6 or 7 kilometres in a million years. So there's the process in a little more detail, just showing you an enlargement of the East African rift. And it's a complex feature. There are bits and pieces that may not go, may be left behind, may come a bit later. Hence, you could have two blocks separated a bit from each other by a small ocean and a really enlarging ocean, or vice versa, where they'd crash into one another. But that's the separation of Tanzania from the Nubian plate in process today. I'm just reading what it says in the bottom. The East African rift is a divergent plate boundary. They're separating. Where the African plate, the process is splitting into two, called the Somali and Nubian. And there's a bit more detail. It shows that those separations are very irregular along the length of it, starting right up near the Red Sea or Sea of Arabia. It's 5.2 millimetres a year, whereas coming down towards Lake Victoria, it's only about 2 millimetres a year. But it also got an easterly rift the other side of Lake Victoria, where it's separating at twice the speed, you might say, locally. And that's the reason you get these funny blocks all separating from one another. The stress is just different in different places. I don't think I need read that again. Get a Nubian plate and in the west, and a Somali plate carrying Tanzania eastward. And it's similar to the separation of Gondwana 500 million years ago, or even of Australia from Antarctica 60 million years ago. And there is a rift still extant along the northern edge, or eastern edge, as we would refer to it, of Antarctica, which obviously which failed and didn't come with Australia. East African rift is developing a divergent tectonic plate boundary where the African plate is splitting into two large tectonic plates or several microplates. And in the same way, a rift occurred 500 million years ago that developed into the first ocean between North America, that is Laurentia, and African Gondwana. This first one was the Iapetus Ocean, and its suture can be traced through Europe and Eastern North America. Of course, it wasn't until the second ocean occurred that you had all these bits moving across to join it. So really, this is the first ocean. Perhaps we know less about it and don't know what fragments were brought across with it. Suffice to say, 500 million years ago, where we were previously, you did have the start of a new ocean, and my black arrow spearing in at about 4 o'clock, from 11 o'clock to 4 o'clock or whatever it is. You can see Avalonia is separated by an arm of the sea, we can say, and is starting to split off. And there's a brown patch there, which is probably Rheic. Didn't quite come as freely as Avalonia, followed it through and became the Brittany Peninsula and Central and Southern Europe. Needn't worry about all the names, but volcanism occurred as a result of subduction of the original Iapetus Ocean in both directions, probably under Laurentia and also under Gander. And that's how those two ocean plates that made up the Iapetus Ocean disappeared. And with the opening of the split between Avalonia and Gondwana and spreading of that ocean, you had Iapetus entirely eclipsed and it disappeared. And Avalonia was welded against Baltica and Laurentia. We see there the start of a Rheic Ocean, not even named in that case, except in my description over on the left. So by 500 million years ago, a new rift was forming in North Gondwana, which split off Avalonia as the new Rheic Ocean enlarged. To give you an idea, I've tried sketching that along with a model that shows you an expanding ocean floor, or ocean crust is a better phrase. That's 100 kilometres thick. Convection currents in the underlying mantle, 100 kilometres down, tend to drag the central portion of the ocean apart. And as a result, you get basalt magma forming and intruding along the rift, along the centre of the ocean. And this expands the basaltic ocean crust, only about 8 or 10 kilometres thick, but it is the brittle crustal stuff that is the floor of the oceans, as distinct from the masses of other lighter material that form the continents, shown in pink on either side. And this, of course, is the process of a constructive plate margin, building a new ocean floor, gradually expanding, a bit like a conveyor belt, is a good idea, I suppose, but going in two directions. And if it's not subducting at all, then it's pushing the two continental masses apart from each other. And Avalonia on the right would be separating from the main mass of Gondwana as a result of that rift becoming a small ocean. That's a bit like the Red Sea, you might imagine. But way up in the 2 o'clock position or 1 o'clock position, the Iapetus Ocean near the theoretical north point, Avalonia is starting to close another ocean because it's pushing towards it. And somehow another Iapetus has to slide in underneath Avalonia, probably resulted in a whole series of red volcanoes in Avalonia. But more importantly, it slipped under Laurentia of North America and parts of Baltica, the Baltic region, and gave a series of volcanic chains there. And that description of the constructive plate boundary at the bottom just says upwelling basalt at the continental rise sourced from hot magma resulting from the heat of the Earth's mantle formed the new Rheic Ocean crust, which spread laterally so that the ocean actually expanded. I'll be interested to know if that diagram causes you some problems, but you can also see I've got a continental fragment at, well, just above the central word Rheic Ocean, just to the right of it. I've got a continental fragment being passively carried towards Avalonia too. It wouldn't necessarily get closer to Avalonia because it's just sliding along with it as that plate enlarges from the centre rift. Okay, pretty much what we looked at before, only I've outlined in red here the central axis of the early ocean, Iapetus. That was probably still expanding, but at a slower rate than the plate was disappearing under the two black zones where the little arrows point in the north situation, Tectonic arc, and in the south situation, Gander arc. You'd had Iapetus Ocean subducting under both those areas, and so you'd have had volcanic chains 100 kilometres north and south of them, north of the Tectonic and south of the Gander, because of the direction in which that Iapetus Ocean was being subducted and disappearing. And provided it wasn't expanding at a greater rate, gradually close up, and Rheic Ocean to south of Avalonia be able to spread more and push Avalonia right up to dock against Baltica and Laurentia. Anyway, to read what's said, Iapetus was the early Atlantic Ocean between Laurentia and Gondwana, and it existed about 150 million years, from 600 to 450 million years ago. So it straddled the 500 million year mark, you might say. And the red line shown here was the expanding ridge of the Iapetus Ocean, and the black triangles or black points are directions of the subduction as that ocean gradually disappeared. Tucked down in the bottom in brown would be Armorica, one of these land masses that became Brittany and a bit of Spain, also spread through central Germany, ultimately. Tale of two oceans. So we're dropping another 20 million years to 470, and then another 20 to 450. So the Iapetus Ocean is probably shown a bit broader in that situation. That's the blue center line of expansion. And the darker lines, I'm talking to the top diagram here, double line running under Laurentia, Greenland in particular, is where that subduction was occurring. And a red line in the bottom is the new rift, which is starting to bring Avalonia northward to close the Iapetus Ocean. I can see a little Great Britain about halfway along that red line on the northern side. Then looking 20 million years later in the southern diagram, Avalonia has moved northward here, and the Rheic Ocean is expanding from the central rift in red. And of course, the Iapetus Ocean has nearly disappeared, a bit like the Pacific, almost halfway under America today. In that case, the Iapetus Ocean is halfway under America, but that's occurring 450 million years ago. Reading what's written there, 470 million years ago in the top diagram, Iapetus was a complete ocean, and the Rheic Ocean was only a continental rift. But 20 million years later, and this is quite rapid in geological term, Avalonia had moved northward on the opening of the Rheic Ocean. It was, of course, on the Iapetus Ocean plate, really. That's a bit of a surprise when you think of it. The rift is actually developed between Avalonia and Gondwana. So I drew that black line on, show where the original rift was. But now, because of the expansion of the Rheic Ocean, it's positioned where the red line is now, but it's pushed Avalonia or carried it northward. And the last phrase is 20 million years later, the Rheic Ocean had opened and half of Iapetus subducted beneath Laurentia. So that's the process of oceans opening and closing another one. Is another presentation of pretty much the same thing. Unfortunately, you've got to get used to the continents all swinging around all over the place. And this is for real. You ask, how would we know where the continents were? Well, if you take a particular rock of, we've marked two ages there, 540 million years, and the one on the right is 460 million years. So you're dealing with a difference of 80 million years. Black spots on the diagram, effectively giving you some orientation for the position of the South Pole at that time. The way they calculate positions of continents is by magnetics. The tiny magnetic minerals in rocks of 540 million years for that left diagram would all register the latitude at which that mineral was deposited or occurs, if it's an intrusion of a granite or basaltic rock or something like that. At 540 million years ago, there would be frozen with it an indication of its latitude. Unfortunately, we don't get longitude, but the little magnetic elements in that rock sit themselves like a spindle or a magnetic needle at the angle of declaration of the field. So if they're actually right at the South Pole, then the needle stands vertical, and so do the minerals. Whereas if they're at the equator, they lie horizontal or parallel to the surface of the Earth. And in between, they're at the angle of north or south latitude, which is a pretty amazing thing. And in that way, you can get a rough idea of where continents lay, particularly with respect to latitude. And if the latitudes are the same, you do your best to join them together by some other story. And if you can't do that, you're forced to put an ocean between them usually. That's the way they reconstruct these things. If we look at Iapetus Ocean at 540 million years, it was good and strong. AC, which is this Avalonia. In fact, the C stands for Carolina because it extended down as far as Atlanta City, probably in the US. It hadn't moved much, but was still polar in situation. You can see the similarity to an Atlantic Ocean today, although the positions of South America upside down and Laurentia essentially upside down are a long way distant from one another. Okay, there are a good deal of twisting around. By 460 million years, 80 million years later, Gondwana made a big twist. And in fact, Africa is showing indications of glaciation at this time. And I've seen that glaciation in the Sahara region, the northern portion of Africa. Australia is coming into that situation by a rotation of Gondwana. And by 300 million years ago, Australia was glaciated, as we know from Hallett Cove. So these continents are twisting around, which makes the story very difficult. But looking at 460 million years ago on the right, we've now opened the Rheic Ocean significantly, which would have been right at the 6 o'clock position in the previous diagram. It's now opened as a broad ocean, and Iapetus is shrinking at 460 million years ago. And as a result, we've got this Avalonia. It's named for the Avalon Peninsula of Newfoundland, and Carolina, or Carolonia, I don't know quite like how they spell that, the yellow plate that's been pushed away from Gondwana. Another rendition of something similar, Iapetus Ocean extending right up towards Siberia. Rheic Ocean, actually in this diagram, is shown effectively on the other side of Baltica. Now, why do I say it's a sort of precursor of the Atlantic? Well, in fact, it was, by the time it's crushed everything together, it did occupy the position of where the word Iapetus is written. It closed the Iapetus without actually following the same suture. The Iapetus Ocean suture we can see very well through North America and through Britain, etc. But the Rheic Ocean suture is never seen on land, as far as I suppose it does run through Poland, Central Europe, but the exposure isn't so good. And in places where you would expect to see it, perhaps in Cornwall or in the very southern tip of Ireland or somewhere, we're not clear at all the details of the Rheic Ocean. There is, in fact, an island or two off the tip of Cornwall that probably represents that suture. Here it's advanced a bit further to 370 and 280 million years. The Rheic Ocean has actually closed, and that's when Pangea had effectively come together 280 million years ago, whereas 370 million years ago, 90 million years previously, you had this very broad ocean mimicking somewhat the Atlantic of today. So we use the word Law Russia for when effectively Baltica or Northern Europe coalesced with the North American continental mass. So it's known as Law Russia. It's portion essentially of the supercontinent Pangea. The cross-hatched area in the right-hand diagram cover old ancient mountain masses. In the United States, there's the, well, I can't even pronounce them, Utah, Alleghenian origin. That's a mountain building phase and sort of coming through Mexico into Florida and Carolina, etc. Whereas we tend to call them the Appalachians, actually cover old ancient mountain masses. In the United States, there's the well, I can't even pronounce them, U3A Alleghenian origin. That's a mountain building phase coming through Mexico into Florida, Carolina, etc. Whereas we tend to call them the Appalachians around New York and running through into even into Greenland, and where we see them today in Caledonian regions of Scotland and through into the Caledonian areas of Norway. With all those mountain ranges had their origin as a result of that closure of the Rheic Ocean. To a certain extent, the earlier closure of the Iapetus Ocean resulted in mountain ranges and volcanic arcs and so forth. But I think most of the deformation and alteration of the rocks, intrusion of granites and things, is better related to the closure of the second ocean, the Rheic Ocean, as shown there on that left-hand diagram. To get an idea again, we had the Rheic Ocean expanding, and in this case, it's carried Avalonia all the way across to crush into Laurussia, and there would have been a trench where it was subducting. We're looking not only at the spreading ridge of the central Rheic Ocean, but at trenches on either side, and more particularly on the right-hand side, where it's subducted against Laurussia and welded Avalonia ultimately against it. And subsequently, the area A, which we can call Armorica, the Brittany Peninsula, the lowlands of Europe, and probably a little bit of Spain as well, was carried in a little bit later and crushed in to the south of the other blocks, of the Avalonian blocks in Europe. So we originally had this spreading, but it was then dominated by subduction, and even the Rheic Ocean gradually disappeared. Just to read about destructive plate boundaries at the bottom there, plate interactions finally resulted in closure of the Rheic Ocean by complex subduction processes which consumed the ocean crust. New volcanic arcs formed as the ocean crust descended into the mantle. That's the story of ocean number 2. Iapetus and Rheic existed for several hundred million years, particularly between 400 and 600 million years ago. They're in the southern hemisphere most of the time, but essentially between the paleocontinents of Laurentia, Baltica, and Gondwana. Avalonia was between them. The closure resulted in Pangea. Now, some of you may say, hang on, this is a story you were giving us last time for the Tethys Ocean, or the western portions of the Tethys Ocean. Yes, indeed. It may well be that the last phases of that Rheic Ocean were in fact contiguous with the rifts that caused the Tethyan oceans through Gibraltar and the Alps as we know them, and through Asia. They overlap in time, but we're really just talking of a closure of the Atlantic region here. But if we think of that block of Avalonia that crossed the Rheic Ocean, or was carried north and finally pushed against Baltica and against Laurentia, that's against North America mainly. We can start from the bottom left. I won't go into great detail, but Connecticut, I think, is really the CT right at 9 o'clock. And then sections of the mountain ranges of the Blue Range and the Appalachian Mountains going northwards to your New York region, and then portions of Nova Scotia, which you can hardly see where I've written Western Avalonia. Above that, there's an NS, and that's Nova Scotia, and Cape Breton sitting up to the north. I think PC is probably where Anne of Green Gables had her existence. What does PC say down there? Oh, PE it is actually, Prince Edward Island, of course. That's actually an E. So that sits above that term Western Avalonia as a little island in effectively the Gulf of St. Lawrence. But then the eastern half of Newfoundland, or it's not half, it's only a third of Newfoundland, I guess, the Avon Peninsula. So the capital, St. John, be just in that cleft to the northern side of NFL, about halfway across the blue fragment of Avalonia. I should have called it Avalonia in the big terms rather than the Rheic Ocean, but the Rheic Ocean is to the south, and the Iapetus Ocean subduction zone suture is along this northern trend. In fact, in Newfoundland, since I'm talking about, there's a very clear line across Newfoundland, which is known as the Red Indian line, and that is the Iapetus suture. Moving further to the island, straight through the middle of Ireland and under Dublin, you might say, is this suture of the closure of Iapetus. And that is almost through the Isle of Man and along the Hadrian's Wall, more or less. And so that it's interesting how major features of continents often reflect these important sutures. Most of England and Wales, etc., were on this Avalonian block. And then the last bits of Northern Europe running through almost to Poland are squashed against Baltica. So there are actually multiple volcanic arcs and fold belts that parallel that northern margin, that suture, called the Laurentian margin, that resulted from the subduction of particularly the Iapetus and subsequently Rheic Ocean. And their sutures are shown here. But the extraordinary thing is the Rheic Ocean suture, the southern line, is not really seen through lack of outcrop in Northern Europe, and otherwise it's hidden by the new Atlantic rift, which more or less corresponds to it in places. Comment there that this block, Avalonia, was derived from northern Gondwana, somewhere South America, Northwest Africa, and was carried northward by the subduction of the Iapetus Ocean and the spreading of this Rheic Ocean. And these are all the present day fragments. And so ultimately, they came from subequatorial regions, southern hemisphere, and they got welded on to areas that were actually almost polar 500 million years ago, or 600 million years ago. That weld is just a pace apart, you might say. The suture between Avalonia and Laurentia is in the Isle of Man, or along Hadrian's Wall, running through the centre of Ireland. But that gentleman's right foot, you might say, is on North America plate at one stage, or the Laurentian plate, and his left foot is on Avalonia. They don't look terribly different, but they're all crushed around a fair bit, and that's the what is described as the suture. Of course, it would have been 20 kilometres wide, I suppose, of faulting and fracturing, but the last rocks you can identify from the two separate plates of that era are now firmly welded as part of Eurasian plate of today, and it's called the Neobel Fault. It marks the Iapetus suture on the Isle of Man. Rocks at the top left are formed in Laurentia, but in lower right in Gondwana. And that's the peculiar story of Great Britain. The two political halves are divided by an ancient ocean, which gets a lot of importance, the Iapetus Ocean suture, because we can see it on land. Whereas, as I said, the one that did all the business of closing it, the Rheic Ocean, really doesn't leave a suture that's visible. Now, if we can work this one out, behind it faintly is the current map. At 9 o'clock position, you've got the Great Lakes, Canada, USA, and Hudson Bay just above the word Laurentia. So it looks a bit on an angle. Then Greenland sits just east of the central axis in the north. And it's marked as the Greenland Caledonides, where all the fjords are along that northeastern side of Greenland. And then, of course, the Scandinavian, well, it's not present day, because here we are, we've closed the Atlantic in this map, because there are the Scandinavian Caledonides crushed against Greenland. And we see in the south Avalonia has marked it very prominently as having been pushed up against it. And the Rheic Ocean is open, with America still to come in and give us southern Europe. But it has closed Northern Ireland and Scotland down against England, and shows how they, strictly speaking, belong on the other side of the present-day Atlantic Ocean. So if we were to draw the Atlantic Ocean suture down there, it'd come down from the 1 o'clock position where the red line is, down the middle between Scandinavia and Greenland. It'd give us Iceland, of course, but it has to swing out and cut into North America to include Scotland and Northern Ireland in what we know today, and then swing out around Newfoundland to separate that from Spain, etc. Let's just refer to the cross-hatching. That's the belt of rocks deformed by the closure of the Rheic Ocean. It's a very broad belt, and it includes the moratonides of West Africa and the Variscan mountain belt running through central Europe, so that it was a very extensive zone of compression and alteration of the rocks, mountain building, or orogeny in terms of a geologist, where there was folding and faulting, metamorphism of the rocks. But the original closure of the Iapetus Ocean, the earlier ocean, is really shown in brown. Its bordering suture is not clearly marked. It's a zone of alteration and folding of the rocks. Whereas, as I was saying earlier, the Isle of Man and the Hadrian's Wall is taken as the actual suture running through the middle of that belt. I think that's probably a good place to stop at the moment, particularly as my watch says 11. Thank you all, and we'll return to do more of this confusing story and try and clarify what happened in the opening of the Atlantic Ocean. Probably go over a bit of this next week. I'll leave it open to discussion. Any questions?